pretty easy to understand. We're just going to name some of these compounds that we've been putting together. And they're really easy. You name the cation. So the cation would be the metal. So all the metals that lose electrons, we call those cations. And they're positive charge. And then the anions, they're going to gain electrons, but we need to differentiate between an actual anion that has a charge and then one that doesn't have a charge. For example, if we have an anion of F, we no longer call it fluorine, because that fluorine is the natural form of it without an electron being added. So it has to be fluoride. Yes, ma'am?
So cation is one word?
Yes, it is.
It looks funny.
It is one word. Okay, so all the endings are going to end in IDE. Every ending that is what we call an ionic compound, and I'm going to put up here, I probably should put up here binary, because binary means there's two elements involved in the bonding. So, naming binary ionic compounds, this is what we use. As you know, a bicycle has two wheels. It's bi. Anything with bi, it is a prefix that represents two. So two different elements coming together. A cation and an anion. The anion's negative charge. All right? So let's just do a couple where we name them. So here's one. CaCl2. We have two different elements hooked together. So we would name that what? Calcium chloride. Calcium chloride. Okay. Let's go ahead and do another one. Let's go ahead and do this one, Li2O. Yeah, and it's not oxide. They're usually one symbol or two. When we take a look at it, two syllables is all they're going to be. So we don't say oxide. We don't say sulfuride. We say oxide, sulfide. We don't say phosphoride. We make them two-syllable words. So that's what this one's going to be. It's going to be lithium oxide. So any questions about that? I mean, that's pretty straightforward, pretty easy. Now, the tougher part is writing the formula, and so that's what we'll spend most of our time on. Any questions you have on that for right now? Okay, we're going to do some other naming here in a second. So questions. I think we'll do is we'll come back to this naming where we have to maybe change some things up in our name due to what we call transition elements. So for right now, that's all you need to know. So then we're going to go on in writing formulas from names. So we're going to go ahead and do our next slide. Would be writing chemical formulas for binary ionic compounds. I think most of you will like this. I'm not ever going to say, I think all of you will like this. But I think a lot of you will, because you're going to have a lot of success doing these correctly, that you'll like it. I mean, most of the time, if something is fairly, easy to get and doesn't take a lot of time, most students will kind of like that. So this is binary ionic compounds, writing chemical formulas. So we've already done a little bit of this already. We've already done some of this already, and this should be an easy transition at this point in time. So if I'm given a name of something, for example, if I'm given the name aluminum chloride, I believe the last couple questions that we had yesterday that we were dealing with we had to do some of this. So, to write this formula correctly, what do I need to do? So what do I need to know before I can start doing that?
The charges.
The charges. Now, you know what? I'm going to make it really easy for you. Most of you realize how a charge is formed, so now I'm going to show you where the charge is given to you on this sheet. So now that becomes really easy because you look at this thing called an oxidation state on your periodic table.
Oh.
So find the oxidation state. It's located above the symbol. So now you don't have to figure out what the charge is. It's given to you. Isn't that nice? Okay, but most of you could probably do it without it. A lot of you could go, I know how to do it without it, and that's good too. You recognize why the charge is what it is. That's that application. So what's aluminum's oxidation state, or charge in this case? +3. What I like to do if I'm given a assignment, I just go ahead and write the word out, and I put my charges above each ion. So what's chlorine, which is actually chloride when it adds on an electron? So what's the charge of chloride? Okay, now here's the deal with the nonmetals, okay, on this sheet. If you look at chlorine, it's got a ton of numbers, doesn't it? It's got numbers. We're going to always look for these. We're going to look at the first number. I shouldn't say the first number because that's not true. We're going to look at, and make sure that I'm telling you right here because I'd hate to tell you wrong and then I get in trouble for that. Yeah. Look at the last number on every single one of these on the nonmetals, and that's the charge you use. You guys see the last number listed?
So the one furthest to the right?
Yep. Yep. Okay? So,
I was just double checking, gosh.
that's good to double check. Okay. There's a ton of numbers there, and we're not going to deal with those numbers for quite a while, those other numbers. They have what we call multiple numbers, but when they're in ionic form, they always take on that negative charge at the end. So you always look at that negative charge at the end. Okay? So it's a -1. So now we write our formula. The formula would be what? Al, Cl, what? 3, right? Because this here, I would have to have 3 of those. See, the 3 on the outside tells me how many of those chlorides I need. And why do I have to have 3 of them? Well, it has to match the number of electrons given up by aluminum. We have to have 3 chlorides except those 3 electrons from aluminum. So when you originally take a look at this, you have Al with the 3 dots. And this will be the last time I do this. I'm not going to do this anymore. But you have to know why it's 3. So here's aluminum. It has to get rid of all 3. And we only have 1 slot on each chloride. So if we only got 1 slot in each chloride, then that means that we have to have 3 of those chlorides come in. So I will never ask you to do this part, but that's where they go. And now aluminum has its electrons all gone and it has the right configuration. So AlCl3. Any questions with that? So what I'm going to do at this point in time, I'm just going to give you about 3 to practice, and it shouldn't take you too long to do them. And then we'll talk about them. Okay? We'll go easy, middle, most difficult one to do. Alright? And then I'll have you do those 3, write formulas, and see what you think of those formulas. So here's the 3 I'm going to go ahead and have you do. Easy, middle, and then the most difficult type that you would have to do. So here's the first one.
The positive charge always goes first, right?
Yes, that's the cation. Okay, so those are the three. Actually, the middle one's the toughest one. So those are the three I'd want you to go ahead and do. So the formula that we would have for the first one, since we have to have 2 sodium, is Na2S. Any questions with that? Okay, since we have 2 sodiums, each of them +1, it cancels out the -2. Each sodium has to give up 1 electron. Sulfur needs to gain 2, so we need 2 sodiums to get it its 2. Okay, we're going to go the bottom one first because that one's easier than the middle. So on the bottom one, what would be, how many potassiums would we need? 3. Multiply by 3. Need 3. So that's K3 in. Any questions you have on that? Okay, and the middle one, remember we said most of the times when we have 3 and 2s and we're dealing with them to where we got to get them the same, we're always going to use what like they do in math, where you have to have a common denominator. 1/3 plus 1/2. You got to get the bottom one to 6, right? So guess what? You got to get both these two to 6. Total charge. Positive and negative. So we're going to multiply that one by 2, multiply that one by 3 to get you your charge. So always remember, if you got a 2 and 3, get it to 6. And you'll have to determine how many of each you need to get. So this one would be Al2S3. Any questions you have with that? Makes sense. Okay? That's about the toughest one you do when it comes to balancing charges. All right? And that's pretty easy if you can understand that and get that. I mean, that makes it a little bit easier. Now, the last thing I'm going to talk to you about is if you look at the middle group, like if you look at group 1, what's the charges listed for group 1? All the way down. +1. Okay. Do you have to guess what charge it is? No. You know what charge it is. Okay. Group 2, do you have to determine between a couple charges or just one charge? Just one charge, +2, right? Well, let's say we go to the middle group and we've got something like nickel. All right? So we go to the middle group and we got nickel. Well, we've got what we call variable charges. And the reason why these are variable charges, there's some electrons that will be taken out of the D sublevel and be lost. So we could have some taken out of the S sublevel, but also the D sublevel. And that's why you're in that middle section. That's those. If you take 2 out of the outer portion, then you're back to the inner level, and then the D's, for some reason, they're not holding on as tight, and they can be taken away. So what's the possible charges for nickel? Can you tell me? Plus what?
2.
+2 or a +3? Well, you have to tell the charge that's being used in the formula. Okay? So, if I have written it out, first of all, we'll write a couple formulas out, but it could be a 2 or a 3. So we'll do it a couple ways to show you which one you would have. Now silver, if you look at silver, what charge is it? Ag. It can only be a +1. So, there's no guessing involved with silver. Okay? Cadmium's another one that's only a +2. Okay? But there's some of them that have multiple numbers listed. And if they have multiple numbers listed, we have to tell what the charge is. If it's a +2, I'm going to use a Roman numeral 2. It'll be nickel 2. Nickel. So if I have this one there, this one's going to be nickel 2. And if I'm using this one here and describing a formula, that would be nickel 3. Okay? So we're going to do this a couple ways. I'm going to go ahead and give you names of some transition element, ionic compounds, and I'll have you write the formula down. Okay? Just like we just did. Okay?
Did you say this was called various charges?
Variable charges.
Variable charges.
So, now, these you wouldn't even have to look up, unless you don't know the symbol of iron. Then you'd have to look it up. But, when I give you iron 3, you know the charge. It's a 3 charge. If I say tin 4, that's the charge of tin. I have to give you the charge, because if I just write iron fluoride out, it could be a 2 or 3. So how do you know what charge you use to determine how many you need of each ion? You don't. Okay? You would guess. And you can't guess. You got to know for sure what ion it is. So go ahead and write out. This is the charge, remember. Okay? Remember, this is the charge for that particular ion. And then you have to look the other charge up and then put it together like we just did. So why don't you go ahead and put those two together. The first one, plus 3, minus 1. So then I need 3 fluorides. So that should be FeF3. Any questions with that? Next one, this is Roman numeral 4. This is a minus 2. So I need 2 of these for every 1, 10. So that would be SnO2. Correct? Any questions you have with that? So now the toughest part of doing all of these is if I give you a formula and you have to name one that has to have Roman numerals. So when we do tests and quizzes, the most common mistake done in tests and quizzes, they do not do the Roman numerals correctly, or they don't even write them out. Okay? They don't even write them out. They know that it has variable charges, but they won't tell me the charge. They'll just say, well, the answer to that is iron fluoride. Okay? Which iron though? Is it 2 or 3? So you have to determine what that is and then write that Roman numeral in. So this is the most difficult part, I think, when doing these. When I give you a formula and you have to write out the name and include the Roman numeral. Okay? So I'm going to give you a couple. We'll do 3.
So you just write what it's called?
You'll have to determine the charge.
Oh.
Okay? So this one you got to do a little bit more investigation with when you do them. All right, I'll do the first one for you. Now, I'll do the middle one for you. That one's a more difficult one, and I'll have you do the top and bottom. So here's what you do. You know that it's going to be cobalt. Leave a little space, because when you look at cobalt, it can be multiple or variable charges. So cobalt could be a 2 or a 3. So I'm going to write cobalt, leave a little space, and I'll put sulfide. So cobalt sulfide. Now, I've got to find out if it's a 2 or a 3. So to do it, just like math, if you have to solve for x, you go through a process to solve for x. You have to do the same here. This is the unknown charge. We don't know what the charge is. Okay? So we do know the charge of sulfur. And the charge of sulfur is a minus 2. But I'm showing 3 of them. So the overall charge of sulfur, the whole thing, is a minus 6. All right? Now I have 2 of these. So the question is, for me to match that 6, what's the charge of cobalt have to be? 3. I found my charge. So when I write it, I'm going to write cobalt, or we'll start it over here, cobalt 3. Okay? So this is the charge that I'm trying to find so I can write cobalt correctly.
Do you want us to write the charge of sulfur? next to it? The 2, the minus 2?
The name for the name?
Yeah.
No.
Okay.
We don't write any charges once we do the name. So do the next two, and they both will have Roman numerals. So go ahead and do the next two and decide what their Roman numeral will be. 2, copper. Okay, so I don't know copper. It's a guess. But iodine I know. And it's a -1. I got 2 of them. So that's an overall charge of a -2. So copper is going to be what charge? +2. There's only one of them. That one means it's a +2. So this would be copper 2. Iodine. Down here, we don't know the charge. Oxygen we do. It's a -2. We got 2 of them. +4. So what's the charge of manganese? 4. So manganese 4. They all end in ides. So that's all the information that you probably would need to do this assignment. And I didn't know how long it would take. It took a little bit longer to do. Tomorrow we won't do anything, but you guys can work on finishing up your board. And then on Thursday and Friday, some of Thursday, all of Friday, you guys can hopefully be, get it done. And we had some people come in today to work on some things, and hopefully a lot of you are really, really close and know exactly what you're going to do. And then the peer review we might just not do. We might just have you videotape it, and then find some way that we can share that with others. I don't know how you guys feel about that, but instead of you presenting twice, you can present once as a video, and then we can maybe take a look at that 2 or 3 minute video for notes and that. So instead of doing 2 things, we might combine that all into the video type of thing. So that would be your assignment out of the book when you have to do them. 22, when you're doing 22, you're naming them. All right? 20, and always double check if you need to use a Roman numeral or not. Okay? That's always a good process to use. Now, if you need a Roman numeral, it'll be the ones in the middle. So if it's not in the middle, or not ones where like it's silver, cadmium, or zinc, which just has one oxidation state. But always double check. It's always good to do. Okay? 24, you're going to have to tell me the Roman numeral that will be used. So that should be really super easy. 26, on that one, again, you're going to do the same as 22. And then 30, you're going to have to write formulas as well as 34. So 30 and 34 are a little bit more challenging because you got to write the correct formula with the charges balance. So let's see how you do on those.